Hello, everyone. Welcome to this Roundup. 3D printing, its digitization and automation is fundamentally transforming manufacturing and so much more. From bioprinting of human tissues and organs to building homes, cars, aeroplanes, prototypes for industrial manufacturing, and so much more. Automated and distributed 3D printing seems to bring nations the potential to be a very disruptive, revolutionary invention. While the 3D printing technology has not yet fully evolved to replace most manufacturing processes in its existing form, the potential of integration and convergence with blockchain, artificial intelligence, and Internet of Things is opening the door for a growing, disruptive, decentralized, automated, and intelligent technology applications that will bring sustainability, affordability, and efficiency across industries. It will be very interesting to see how will blockchain, Internet of Things, and artificial intelligence propel 3D printing further in the coming years. As integration of this 3D printing technology transforms, most manufacturing processes and millions of people will be able to make, copy, swap, trade, buy, and sell all their everyday stuff with which they operate and secure their lives. The impact of 3D manufacturing on nation's economy and way of doing things is going to fundamentally change. While there are still so many more hurdles in the 3D printing process that need to be overcome for widespread adoption across industries, 3D printing seems to be here to stay. To discuss the potential of decentralized, distributed, automated 3D manufacturing further, I'm delighted to welcome Josué Batista to Risk Roundup. Josué is a technology strategist and is based in the United States. Welcome, Josué. We are delighted to have you on Risk Roundup.
Thank you so much, Dr. Pendra. I am also delighted to be here. Thank you.
Wonderful, Josué. So, as technology lays the foundation for a better tomorrow, the outdated concepts across industries are making room for modern, efficient, affordable, and distributed future. How do you see 3D printing evolving, and which industries do you see are on its way to getting transformed?
Well, I see 3D printing as the probably one of the most powerful engines, what we call the fourth industrial revolution. This fourth industrial revolution is about knowledge, leveraging knowledge, and what I call the democratization of expertise. So having the 3D printing options as they are evolving to democratize the manufacturing, as you mentioned, from bio design of human cells to building specialized parts anywhere in the world. That is the vision that I see as a futurist, as a technologist, how this is going to evolve. I can just imagine places in the world where perhaps there is no manufacturing capabilities today. Well, in the future, there may be equipment that is connected through mesh networking. There is no need to even establish infrastructure for that. I can see how the protection of the intellectual property on equipment can be protected via blockchain. Artificial intelligence and IoT with sensors and authentication can ensure not only that the parts that are being produced are post-production that are okay, but during the production process, there is technology available to actually verify that the provenance and the authentication of those parts is correct. So I think the future is bright. I think as a technologist and a business strategist, my job is to make people aware that these technologies exist. Because you probably know this, most of us are busy in our day-to-day, in our activities, in our jobs, in the companies that we lead, and we may not have an opportunity to understand how impactful 3D printing is going to be now and in the future.
Yes, absolutely. No, you made a very right on the comments about how this transformation that we are hoping that 3D printing will bring is going to fundamentally change everything. And it is not only what we see, like, initially we were hearing all these news about that there are people printing guns using 3D printing technology. But now we hear so many news coming from across nations, from China and from Europe, and that they're even building homes using the waste that construction industry just leaves behind. They use that waste of the construction industry, and they are able to 3D print the entire small homes for a lot of people. So this is a very transformative technology, and the potential of getting it decentralized, that we are able to send the digital print of all these the way to manufacture, the way to produce these things, and we don't have to have these huge manufacturing facilities across nations. Wherever we need, we can instantly print. We won't have to print a lot of things, or we won't have to manufacture a lot of things and print it, or keep it in a warehouses or manufacturing facility. That itself is a big disruptive trend. So how do you see this 3D printing changing this traditional manufacturing industry? Because we have already started seeing some really good stories coming from across nations. And where do you see, what is the current state on that? I mean, probably you have researched this more than I have, that where do we stand on this traditional manufacturing industry transformation?
Sure, sure. I will say that I keep myself as informed as I can, but you probably know that there are verticals where there is a lot of specialized knowledge. But I see from the trends that I have gathered, I see two parallel tracks happening when it comes to 3D printing. So 3D printing, for example, when it comes to bioprinting, in terms of printing living tissue or cells, the technology is not as advanced, for example, to create the tissue that is needed, for example, for a kidney. The cells and the tissue needed for the kidney, the technology is not small enough to print that is small enough to filter, the fluids that typically, a normal natural kidney does. But that technology is evolving. So in the future, there is going to be a specialized field related to bioprinting, with very specialized knowledge and techniques, and I cannot even wait to see where that is going to take us, because I can see in the future complete organs being created with living tissue in them, and the technology is going to get there at one point. The other aspect that I see is the creation of specialized parts in the meaning that they have very specific materials that need to be built, specific, very critical specifications. The use of that has to be regulated. Like, for example, parts that are used in planes, every part that a plane has to be tracked, which for that, by the way, blockchain is fantastic to do that immutability and traceability. But then you get into the risk associated with, okay, if I'm printing this equipment that is going to go into an airplane, I want to make sure that pre, during, and after the creation of that part, I have complete traceability, not only on the provenance, meaning where that part came from, but also the materials that were used. And today we have two ways, basically. I'm oversimplifying. I know there's many experts listening to this they know much better about the techniques that are used to authenticate parts. But basically, oversimplifying, you authenticate the materials before, right? Making sure that the provenance is right and the raw materials that you're using are correct. And then you have, post the creation of the equipment, you can probably do some tests. Actually, it's done to ensure that the part actually is up to the specifications. But what about during the process, during the time that equipment or that part is being created? And that is where the beauty of artificial intelligence, the Internet of Things, mesh networking are going to make this flourish and go everywhere. Because, for example, there is today availability to create molecular ink, and where you can place a hash that is unique to you. What if in the future, the raw materials that we use to create these parts have in them that molecular ink with that hash that actually authenticate that comes from that manufacturer? This has nothing to do who brought that physically, but actually the material itself has a hash in it. And we have IoT sensors that can read in real time that that part is being created with the right material from the right place with the right specifications. So that eliminates the pre and post problem that, tracking the provenance up to the point of creating the part, tracking after the part is created, during the time that that is done, that can be traced, that can be tracked, and the blockchain would be a great, as the vault of those decisions, could be a great way to keep that immutability and traceability in place.
Oh, I think you made a very excellent point about that. I mean, the potential of this bioprinting, think about it, we'll be able to print the organs and, tissues and even at the molecular level. And if we are able to track all that, and we'll be able to save not only so many lives, but we will be able to also reverse and delay this aging process, and people will be able to live for so much so many more years. That is amazing. I can't wait for that either, to see the potential of bioprinting. But at the same time, there is also this, if we are able to track each and every weapon that is manufactured, and the parts that comes, where does the raw material comes, where does the raw, different components that goes in any of the weapon, irrespective of whether we are talking about bioweapons, nuclear weapons, or cyber weapons, or any weapon. If we are able to track each of that, then we'll be able to prevent so many crises or so many attacks that are happening across nations, and we will know who owns which weapon, and where the threat is emerging. And the security industry can benefit so much by having everything tagged and having everything on blockchain, and then having this 3D printing capability. So we would know in real time who is printing any weapons and where it is going to be used, and where the AI layer on that will be able to give us a very intelligent, precise location, and will help us mitigate those security risks emerging. So the potential is very transformative and great, and I can't wait for everything to get on blockchain. And if we are able to do that, then we, using the IoT and using the AI layer, and using this 3D manufacturing capability, we'll be able to have a very clear, transparent way of knowing what is happening across nations. But for that, we'll probably have to wait for decades. We are nowhere near that. This is the beginning, but we have a way, the vision that, a lot of people have, is that we'll be able to reach there. And if we are able to reach there, then we are going to be able to manage a lot of security risks that are, right now, we are witnessing across nations. And it's very difficult for us to be able to manage those security risks because of just the nature of it. So that is, one great, transformative potential that I am looking forward to having, that using this 3D printing technology. But how that is, about the efficiency and all, but people are also saying that the 3D printing is going to bring us cost effectiveness. How do you see 3D printing integration with all these technologies is going to bring us cost effectiveness or affordability, or a cheaper way of manufacturing a lot of things? How do you see that fundamental transformation coming because of as far as cost economics go?
Right. So again, that is part of what I see, an evolution of the technology. As the technology becomes more efficient, as we add more innovation, and we can leapfrog instead of building the scaffolding that we have done traditionally to build and manufacture things. So, for example, I believe that the cost efficiencies of mass manufacturing are going to be here for a long time. So for parts that are noise specialized, for parts that are necessary for day-to-day activities, cups, things that we use day-to-day, most likely the most cost-efficient way to do that is through the traditional mass manufacturing, which, by the way, when you add robotics into that, the cost efficiencies that some companies are getting is mind-boggling. There is a company in Germany, for example, that I did you can watch one of my videos, it's called KUKA, and they build these wonderful robots that are used primarily manufactured, that are smaller, that are easier to set, that are intelligent, that are smart, and manufacturing is being revamped entirely when it comes to the mass production. So mass production always going to exist there, right? What is expensive today? What is expensive today is specialized parts. So think of parts that are needed in for medical implants, for example, or for replacing bones or replacing, kind of physical parts within the human body. Those are very expensive parts today, right? Because they require not only the regulation that goes along with that, because you don't want to be placing parts that are going to damage or perhaps cause harm on an individual. But also the materials that are used are very expensive, and the process of creating them is very expensive because they have to be to specifications. That is the area that I see as the low-hanging fruit for 3D manufacturing. Is specialized, unique, customized printing, whereby using the innovation that is already existing, we can print those equipments and those parts anywhere in the world. So it doesn't matter if you are in a small village in Africa or in a remote place in northern India or in some place in South America. As long as you have access to that equipment, the IP and the software needed to print that device and the materials can be traced, to print those places there. That would really diminish the cost. Because today, when you account for creating the parts, the materials that you need to use, the transportation or the availability to get that to the place where it's needed, all that add cost to it. So those are the opportunities I really would like for companies to start thinking. It doesn't matter if you're in banking or in insurance or finance, you are going to have an interaction with organizations and companies and individuals that are going to be in that space. So you need to know what the advantages are of using 3D printing. So I see some cost efficiency short-term there in specialized printing. As the technology gets more, more efficient, more clever, and we add more intelligence to these machines, then we're going to go into a more of a mass production. Like, for example, today, some of the comments that I got from my article and research on it is that today 3D printing is relatively slow. So to actually produce a part, it takes, relatively speaking, compared to mass production, it takes longer, right? But that is changing. There are more efficient machines that are being built nowadays, and there is already equipment that is, factors of X faster, but it still is not as fast as in mass manufacturing. So the opportunity is, as I said before, in a specialized, customized, unique printing that is needed for those specific, medical, industrial, aerospace, parts that are very unique, very specialized, that are needed at a specific geographical location, whereby the people there can have access to that. No need to wait until that part is built across the globe and being shipped to that place and then find out that these specifications are not up to date. All that will be pretty much complemented with that traceability.
No, that makes sense, and I agree with you on that. But I think what we see the current success is more about the standalone silo, 3D printing manufacturing capabilities. But if we are converging it with blockchain, and if you want to send the digital design of all these, intellectual property, if you want to manufacture a car or some other specialized manufacturing, then to even be willing to send that digital in a digital format through the blockchain, and to have the distributed capability of sending those digital designs and having a decentralized additive manufacturing, that's probably, I think, the term that is being used, additive manufacturing, for manufacturing processes that are digitized and are done in layers. So if do you see that kind of willingness from innovators or corporations that they are feeling comfortable enough that they want to have the digitized, they are willing to go forward to have the digitized version of their intellectual properties on the blockchain?
Well, I see that as well as a progression. It's going to be progressively elaborated in terms of adoption. And that is part of what you as a leader and someone like me, I believe that is part of my job, to communicate the what and why about protecting the intellectual property. So when it comes to that, for example, I know that the adoption is going to be slow because you're right. Many organizations are very protective of the IP. However, something like blockchain could be that decision vault. It could be a place where not only you're trusting the technology and the encryption in order to protect not only the models, for example, that you're using for a specific part, but also the decisioning process associated with the creation of that. That is what I call the decision vault. So as companies get clever at using blockchain, again, blockchain at this point is not going to, it's too early at this point. It's pretty much a big hammer looking for a nail. So we are all trying to understand the potential. It's a very simplistic technology, right? It's basically two things you can do with blockchain: write and read. You cannot delete, you cannot erase. So, and it's distributed. You don't have to trust the participants of it. So from that premise, adding that to the immutability and the traceability of blockchain, that is an ideal place to actually protect your intellectual property. There are organizations right now using blockchain, for example, to protect intellectual property on musicians, music, art, things that are more in the intellectual aspect because they are not necessarily physical. Blockchain is perfect for that for two reasons. One, you can authenticate that you are the creator of that. That is immutable. Once that is there in that block, you have proof forever, as long as that block is distributed, that you are the creator of that, the owner of that IP. And secondly, you have the capability to grant access to that IP totally or partially to whoever is the known party that you have authorized to access that IP. And that could be distributed. You don't have to, if you are a musician, for example, and you create a song, you have now more options to monetize your song and actually make sure that you are the person that are consuming that, you know who they are. So that brings a complete different paradigm as to how do we see intellectual property for the future. I see a complete range of options. So you have options in which you want to be very close in terms of protecting your intellectual property. Blockchain is going to allow you to create that environment in which you allow only certain unique permissioned parties to access totally or partially that information. So for example, our medical information, right? So today there are companies that advertise on TV and other places to do a DNA testing for you to find your ancestry, right? What very few people know is that if you do a little bit of research, it doesn't take that much, find out that when you are actually sending that sample, if you are not aware of that, you're actually giving those companies permission to use that DNA by other means. And they actually make more money when they get your DNA than the money that they got from you by paying for that service. But in the future, we are going to have more control of our intellectual property, which is us, right? Our bio property. And we will have not only the option to know who is using it, but also grant permission totally or partially to what that is. So that is evolving. I think it's going to be a rapid, we're seeing a slow increase in the awareness. People who make decisions in organizations need to be more educated. They need to be more inquisitive. And it's our job to actually make that easier for them, to explain what are the functionalities, what are the limitations, what are the constraints. It's not going to happen overnight. There is a lot of hype into this as well, because people get excited about blockchain. There is a lot of confusion, blockchain and cryptocurrencies as well. Some people are very close to even have a discussion about blockchain because they equate that with Bitcoin and some of the speculation that exists today in that space. So it is part of my job to demystify blockchain, show the strengths they have, some of the limitations that exist today. And in terms of intellectual property, I think that is a tool that is very extremely promising to, again, protect, store, and authorize access to intellectual property of every capacity, from music to the design of that specialized part that you need for that spaceship.
Sure. No, I hear you. The potential is there. In theory, there is so much that we can achieve, and it has much better security aspects also as far as, blockchain goes because of the encryption and all that. But at the same time, when we are thinking of transferring the digital files of, some really important, initiatives, or then the question that comes here is that which blockchains are we, going to use, or are we planning to use? On which blockchain is going to be transferred all this digital data? Does that blockchain, if it's Ethereum or others, does that blockchain has enough capacity to hold that much data? Does that blockchain have enough capability to scale? So there are a lot of concerns emerging on the existing blockchains, because if we are trying to redefine, redesign all these initiatives on using blockchain, and if we it will require great computing power, it will require a lot of energy, it is going to require capability and for scalability, and there are a lot of questions emerging about whether the current existing blockchains has all that, and whether we can scale or develop global solutions or have this kind of digital data transferred on those blockchains. So I am not convinced that the existing blockchains that we have are capable of transferring these, or have these digital supply chain or digital additive manufacturing processes on blockchain, and we'll be able to scale it in the manner that needs to be scaled, and we'll be able to store all that data that will emerge in those blockchains, because I just don't see that capacity in the existing blockchain. But that is a topic of another discussion. How many initiatives do you see are underway for the blockchain integration with the additive manufacturing across nations?
Right. So if you allow me, I want to just touch. You brought a very important point in your last statement. Actually, a couple of important points, and I'd like just to add a couple of details on that, because I think they're extremely relevant, and they could be, if we understand them well, that is going to allow us to actually leverage more what the blockchain, IoT, artificial intelligence triage or trio is going to help additive manufacturing. So first of all, I am not advocating, have never advocated, and there is a lot of people in the industry, we are not advocating storing data in the blockchain. The blockchain is not necessarily a data storage. In fact, it's very inefficient. It's very inefficient to store huge amounts of data in blockchain. Blockchain is more better suited to store decisions that are made in a flow of artificial intelligence. Remember, there are going to be more and more millions of devices over the next few years that are going to be intelligent, that are going to be making very smart decisions for us. We want to capture those decision points. We don't want to capture necessarily the whole data that they're doing, but the decision points, because we want to have that traceability to go back and say, why was that decision made at this point? Well, we need to trace that back. So first of all, blockchain should not be used to store data as a traditional databases. So it's a different structure. Secondly, blockchain is getting much better when it comes to what you were describing, consensus. Bitcoin was the first success story for blockchain, because Bitcoin is on top of blockchain. All cryptocurrencies run on top of a blockchain infrastructure, okay? Bitcoin was the first success, and you're right, today Bitcoin uses what is called proof of work as the consensus mechanism in order to all those ledgers that are around the world to have the same ledger in sync. They use proof of work. That is extremely cost prohibitive when it comes to keeping all those computers running. The computational power that is needed is significantly high. Why? Because it's a permissionless network. You don't know who is there. So the only way to ensure that no one takes over that network is one computer, one vote. That is how it works, in this case. But then the commercial side, the corporate side of blockchain has a whole selection of consensus options that do not include the computational power that is needed. For example, Hyperledger Foundation is run by the Linux Foundation, and Hyperledger was originally a tool that was created primarily by IBM. In fact, what they call the fabric was created mostly by IBM, and they open source it, right? So, for example, that one uses Sawtooth, that is one of the tools that they use for blockchain, uses elapsed time as consensus mechanism. It's not computational power hungry. It is very efficient, and it works well. Fabric uses an advanced way of selecting voters and leaders to make the consensus. Dash, which is a cryptocurrency, uses instead of using proof of work, they use proof of stake. So in proof of stake is depending on the amount of money that you have invested into the network, you are randomly assigned and you have better chances to be assigned to actually write the next block. So there are options out there, and I think we're going to see an evolution of that. And the transaction speed is getting faster. We just had Hyperledger doing thousands of transactions per second. So there is a lot of new things happening in that space, which would allow us very shortly to have commercial applications of blockchain with no computational power hungry consensus mechanisms and with more clever use of the application, not to store data, but to store the decisions that we're making and the models that we use for the decisions.
Sure, that's a good thing. That's a good thing, and I'm glad to hear that. But if the blockchain doesn't have to store the data, then where is the data going to be stored, and how will that data be made available for verification, or for how will the AI layer be able to access that data in a timely manner? Because if we are trying to make speed and efficiency and all those variables be part of this blockchain, then we will have to make sure that the data access and data availability also happens in a very efficient manner. So how will that happen?
Well, for example, let's take a very simplistic example, because that is an excellent question. So if we do not store the data in the blockchain, how do we ensure, for example, first of all, let's set aside the speed, but let's go to the very important question that you posed. How do we know that where that data is the correct data, right? Well, that is what hash is coming to place. Because if I store the hash associated with that song, with that design, with that software part that I'm storing, that digital thread that is going to take me to that repository, then I can authenticate that I store the hash in the blockchain. I know that the hash exists, is pointing to manufacturer A or B or C. And if I need the software in order to build that part, I can go to that manufacturer. They will have a smart contract that authenticates me as an approved manufacturer, right? That have the machine, authenticates the equipment. And when I get the software with the design, I can compare that to the hash in the blockchain to make sure that no changes have happened. It's not different than the hashing that exists today to ensure that when you are paying with Bitcoin, with Dash or others, that those coins are yours and you are the person authorized to do the work. So hashing and cryptography are evolving tremendously to ensure that it's not as important where the data resides, but the relationship that exists between the party consuming the data and the data repository. So data can be reside anywhere in the world, and right now it's very efficient. In fact, in traditional manufacturing, the data is distributed actually. It's just that from a logical way, centralized because companies control the access to that. In the future, that control will be distributed, still with access controls in place, but that pointer to that place could be authenticated using hashes to make sure that the file that you're receiving is exactly matches the hash that you have. So that will ensure that you are nothing got contaminated, changed, adulterated from the point of storage to the point that you're receiving it.
Sure. I mean, that's where I think the digital thread, is the key concept probably at play here, because as we put all this information and data on the digital thread, and everything is digitized. So if we are looking at the data that from the initial design of any of this manufacturing process, then from the initial design concept to the finished physical part, everything that happens in between will have to be digitized. So this digital thread that we are developing, and that is, being evaluated in many different industries currently, it's more like a complex, connected and data driven events that are happening, that needs to happen for any of these 3D manufacturing or additive manufacturing process in digital format to go through. So as these design and testing and production and use of these uh, digital data or the digital thread is happening, how are the scalability and mass adoption of these industrial level processes being tested? What are the, is it like a seamless process that is happening, or are there any complex challenges that are being faced by these manufacturers as they try to digitize all these, from concept to production?
Right, and again, it's going to happen. My feeling from what I see in the industry happen is going to be the adoption is going to be opportunistic. So you're going to have manufacturers that are going to see, for example, blockchain and the hashing technology that allows to authenticate that as they, for example, in their own organization, in their own with their own partners, when they distribute the software designs, ensure that there's trace and also the authentication of that happens, right? So that is one aspect that I call a low-hanging fruit. You can grab that. It is available. You can implement it in a private mode. It doesn't have to be open to the public. It could be permissioned within your network of suppliers and perhaps value-added manufacturers that you may create a part, or you do the design. Maybe you're a design company. Your job is to design parts. In that way, you avoid piracy. You avoid that design can be altered, because there will be a hash that you are the owner as the private key of that hash. You can authenticate that whoever is going to, before they print that part is authenticated that I, as a designer, created it. So that is one aspect that I see significant opportunities for organizations right away to start using hashing technology within the blockchain to take advantage of that.
Sure.
Midterm, I see devices becoming more intelligent. The devices that actually perform the activities of creating the additive manufacturing. As that evolves, we are going to see more of a democratization, what I call the democratization of expertise, meaning that you don't have to be an expert in biotechnology to print a part that is needed to repair a heart, right? That could be a trained technician somewhere, anywhere in the world with the right equipment and the right technology to print that part. So that is going to bring a complete different space that we haven't seen yet how far that can go, because
Sure, but let me
you have to travel to a specialized place, right, to get that.
Sure, but let me interrupt here. If somebody, who is not in the, let's say, biotechnology sector and prints something from that, for their personal, we don't know what use they are going to do, what they are going to use it for, the part that they are printing. So how do we ensure that anything that is being printed, like, or the raw materials or equipment or processes or even finished part, that, what purpose that is being printed? So how would we ensure the, not only the quality assurance, but also the use, where it is going to be used? Because now anything can be used from across industry to make something. Synthetic biology and CRISPR gene technology, there are many, uh, technologies that are emerging that will be used for producing or creating things that we will have no control over, and we won't know. The democratization of knowledge, information, that is happening across, nation, because of the internet, and everything is on the internet. So it creates a lot of complex challenges also. So this digital thread, we will need to ensure that everything on that, irrespective of raw material or design or processes or finished part, that it will have to meet the quality assurance of many different nations, or individual nations, or that we need to know who is using it for what purpose. How would we ensure all that?
Well, I don't think there is an easy answer to that. I think fundamentally, security and risk management is about building layers, right? You don't have one barrier against risk, or risk management is about building different layers. So yes, I don't think there is technology today that is going to prevent someone somewhere in the world to take a 3D printing machine and build a part that could be done with no specifications and can be sold to the detriment of the user, right? Because perhaps the consumer of that part, they may even be able to falsify perhaps where that part is coming from and the materials that were used. But again, that is where I see the opportunity for the digital thread to come to the rescue. Because as we are better, more knowledgeable and better aware of how this digital thread works, you know, if I am a consumer, if I am a manufacturer and I need parts, and I am aware that there is a blockchain associated with those parts, I want to understand it. I want to make sure that I am aware that how does that traceability works, how the provenance works, how can I access the blockchain to ensure that the part, what not only is coming from the place that is supposed to come, but as you said, the materials that they were used to build the part were the correct materials. And that is where technologies like, for example, the molecular ink that is being developed. There is several companies building molecular ink that it not only allows you to print a unique hash, physically to print something, but the ink itself has a unique signature that actually can be associated with your own private hash. So that is going to create a significant opportunity for us to trace and track through blockchain parts and that they come from the right place. Because you may be able to falsify or counterfeit a barcode, a lot number, but what about the ink that you are using to print that on that box? What about the biomaterials? I think the future I would ever see, even the packaging that is used, even the actual material that is used, the raw material, has a unique digital signature that can be stored as well. We may not have the equipment today to read that real time, but that is changing. There are companies already working on that. So I see the future being a place whereby you will be able to take a part, put it through a sensor, and actually authenticate that with the blockchain, that what you're reading from that in terms of the unique composition of that part is traced back to all the different sources of the materials and the people or machines that created it.
Yeah.
Again, that may be a years in the future, but I think we're working in that direction.
Yes, I think so too. And I think you're right that everything will perhaps need to be tagged. We will need to know where things are emerging, where it is going, and for what, it is going to be used, whatever anybody is trying to print. So, but let's go back to the question that perhaps we could not discuss. How many initiatives are emerging across nations using this digital thread or, distributed, automated, additive manufacturing processes?
Well, I see here in the space that I am directly associated with, because I am in the healthcare space, right? So in my company that I work for, we don't build parts. We are pretty much a payer, an insurance payer, and we own hospitals as well. So I see, for example, in the space of the hospitals that we own around 9 hospitals in the Pittsburgh area. I see there an opportunity for them to start having discussions as to, the parts that they need. For example, the Da Vinci robot that is very popular, very many hospitals are using the Da Vinci robot. We have it in our hospital, right? And it's being used today to perform surgeries with doctors from all over the world. As long as you are trained in the Da Vinci robotics, that doctor can be anywhere in the world and they can just interact with us. Well, the parts that are needed for replacing, a valve in the heart or a tissue that is needed, well, eventually I see that as an opportunity for us to get as well into building those parts at our hospitals. So you don't have to wait for the part to be perhaps created in some other place. It could be more specific to your unique, size or your ergonomics. And better yet, there is technology now that is coming to place in which even there is the opportunity for the immune system of the body to be better prepared to actually adopt that part, that is being placed. So I see that in the space of healthcare, because it's the one that I'm closest, an opportunity there for us to take advantage of this additive manufacturing. Now, if you are in aerospace or you are into chemical parts, chemical solutions, and there's a lot of new things there. I'm not that familiar with that space, but I must say that when it comes to healthcare, there is a whole world there.
Great. No, that's a huge potential as far as the healthcare industry goes. So, but what are the concerns that healthcare decision makers have as far as this additive manufacturing processes for the healthcare sector?
Right. So the concern, I think we already touched, but let's touch base on that, but let's summarize it. The first one is provenance, right? So making sure that the part, even if the part is being created at the hospital, because that is what I see in the future happening. There's going to be equipment at the hospital to actually build those parts. It could be parts for replacing, let's say a bone part that is needed, or maybe a prosthesis that is needed. I can see that already happening in some hospitals. They can build prosthesis actually today. So how do you ensure that the raw materials that you're using are the right raw materials? That would be terrible if someone alters the material that you are receiving, thinking that it's the right provenance, and you can cause harm to a patient, right? Because that was built with the raw material. So when it comes to provenance, that is a risk right there. When it comes to the provenance of the raw materials that you're using. I see also another point of risk associated with the software or the design that is used to create the part. Our equipment is vulnerable to hacking. What if someone hacks the raw material, perhaps the raw design, because those designs are valuable. Some of them cost thousands of dollars, even just to design a prosthesis, right? So that could be valuable to someone with bad intentions or trying to profit from that, to steal that information, right? So how do we protect that from being stolen, right? Or being altered? That is another point of risks. And then finally, if we are providing that part, let's say that we have in our hospitals, we decide to have a centralized place to create these parts, and we distribute those parts to a more, perhaps to the home of the patients, or perhaps to another facility, or we become suppliers to other hospitals. How do we trace that? Make sure that the part that we created here is the one that is being delivered. So again, that goes back to the risk that we identified at the beginning: provenance and authentication of raw materials, authentication of the equipment and the design, the intellectual property design, soft design that was used to create the part. And then after the part is created, how do we ensure that when it comes to the final person or individual or machine that is going to consume it, the traceability is there as well.
Yes, sir.
Right, and there's different options for that. There are traditional options, but I think the beauty of blockchain is because of the distributed nature and because of the simplicity that it brings. You can only write and read. And there is immutability. It's distributed. You can no erase it. You can no alter it. Anyone that tries to alter that, you're going to know that was altered. So I think that is the perfect framework for us to have a discussion as to, let's have a conversation, from an organizational perspective. Here are the risk points. I just identify high level, oversimplifying 3, but there may be many others. Let's identify those risks, right? And let's set up a strategy for managing the risks. It may be impossible to eliminate them, but how can we minimize and manage the risk? What technologies are available today? Blockchain, artificial intelligence, mesh networks. There's plenty. And we need to be open-minded that sooner or later, those technologies are going to be here. If we are late to adopt, someone else is going to adopt before us. We have seen cases, for example, that in some organizations, you may not know that one of your clients may be using robotics to interact with your own software. It's not a human actually interacting with the software that you created. It's a robot. It's a robotic application that they may be using. So you may not be adopting the technology, but maybe one of your suppliers, vendors, partners is already using that. So I think that is important to bring the awareness in my organization and also to others that emerging technologies are here to stay. You cannot hide the sun with one finger, right? So it is a matter of being clever, being very open-minded, and actually allow for education to happen, for that awareness, what I call the what and why. You don't need to be an expert in the how, because we don't expect executives to be experts in additive manufacturing and blockchain. But I think there is an expectation that you should understand what is it and why it's important. That is what I am advocating all the time.
Very true. No, that is the whole goal of Risk Roundup, that we want to collectively create education and awareness of all these disruptive technologies and technology transformation and nations preparedness, and bring it to everybody's attention that these are the security risk emerging from that. These are the different areas when we need to address, where are the gaps and challenges. So having said that, what would you like to tell our global viewers and listeners, and especially those young bright minds who are trying to innovate and make a difference for many problems that they see, their industries are facing or their nations are facing?
Well, first of all, keep at it. We need more of that. We need more people thinking about the future. The problems that we have today cannot be solved with the issues that we created, the way that we created thinking, in the way that the past. We need to move on to the future. The industrial revolution that is happening today is that combination of computational power, artificial intelligence, mesh networking. All those technologies are going to create a brighter future for all of us. And the accessibility, what I see is the accessibility of knowledge is global. So if you have access to the internet, even if you are in a place like I grew up in Venezuela, for example, people there don't have access today to much technology because it's a very poor country, right? In terms of the social problems that they have. But if you have access to the internet, you don't have to pay to learn about nanotechnology. You don't have to pay to learn about additive manufacturing. There is a plethora of information available. So to young individuals, young people that are thinking about the future, stay hungry for knowledge. I think that is the best advice that I can give you. And be inquisitive. Ask the right questions. Ask the what and why. And of course, you're going to learn the how, the where, the who, and all the other W's. But the what and why are the important things. Remain curious, because that is going to make the future better for everyone. And I think the time that we're living is, we are carrying these devices in our pocket. There is more computing power here that was used actually to put the first man in the moon. And, I know that some people use it for gaming, and I know there is a push, for that, but I wanted to use it to create new things, right? To create a better world for all of us. And I think that is important.
Yes, that is an excellent advice. So thank you so much, Josué, for participating in Risk Roundup today. We appreciate your thoughtful insight on the much needed thought leadership on blockchain integration with 3D printing. And our global viewers and listeners will benefit tremendously from the information you provided on the need for blockchain and AI integration for the future of 3D manufacturing and or distributed additive manufacturing. So even if a single individual or entity can join in the efforts for the future of distributed additive manufacturing based on the understanding they receive from the discussion we had today, this Risk Roundup dialogue has been of service, and we thank you for that.
Oh, thank you so much. And please follow me on LinkedIn. I have my What and Why First blog, and you can find more details about my thoughts about additive manufacturing and many other emerging technologies. And thank you so much for the opportunity.
Wonderful. So Risk Roundup, a global initiative launched by Risk Group, is a security risk reporting for risk emerging from existing and emerging technologies, technology convergence and transformation happening across cyberspace, geospace, and space. We at Risk Group believe that risk management, security, and peace, they walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. It is not possible to conceive any one of the three without the existence of the other two. All three concepts feed into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security, so if we build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the Risk Roundups, to watch the Risk Roundup webcast or hear the Risk Roundup podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayshree, host of Risk Roundup, signing off. See you next time. Thank you.